Alrighty, so this is page 4. Apologies. So this is going to be the middle third of page 4, 5, and 6. So we are now asked to explain whether the two lines are parallel. And so again, please note that we don't have any markings that guarantee it, so we have to go through the angles. We can also note that if we look at these angles, the position they're in is that we have them on the alternating sides of the transversal, and we have them outside of the lines. And so these are going to be definitely alternate exterior angles. Okay, so let's get that out of the way. Okay? So if the lines were parallel, we have to ask ourselves what would be true about the angles. Okay, so if the lines are parallel, if lines were parallel, then I would say that the angles would have to be congruent. Let's keep in mind, if we're talking about the converse of these statements, if we're talking about the converse, we're saying if the angles were congruent, then we can claim that the lines are parallel. Okay, so this is the converse to the alternate exterior theorem, angles theorem, okay? But if we look at our diagram, that's not the case. These two angles are not congruent, therefore the lines are not parallel. Okay, so ultimately the answer to this question is no. Okay. Since the alternate exterior angles are not congruent, the lines are not parallel. And that's really all there is to it. And so this just reinforces something we talked about before, which is that these theorems work in either direction. And so if you have parallel lines, then you know you have congruent angles. Reversing it or conversing it, if we have congruent angles, then we know the lines are going to be parallel. And that's not the case here, and so these lines definitely are not parallel. Okay, let's get into some angle theorems, shall we? Or some angle calculations. And so we're back to the triangle sum theorem, where we have the angles of a triangle. Let's recall the triangle sum theorem says, if I have the three interior angles of a triangle, then those angles must be supplementary, meaning if I take 5d plus 4, okay, and I add it to this red angle, which we know to be 90 because of the markings, and we add that to 61, which is our last blue angle, that total has to be 180 degrees by rule of supplementary. Let's clean up. So we have 5d. Okay, so I have 90 plus 61 plus 4. So 90 plus 61 plus 4 is 155, unless I mistyped. Okay, so now we can solve out a little bit of algebra here. Let's subtract off the 155s. Okay, so 5d is the same as 180 minus 155. Divide out the 5s. D equals 5. Okay, now let's try that back into our, we only have one expression here, it's the green one. So we have 5 times d plus 4, so that'd be 5 times 5 plus 4. That would give this angle to be 29 degrees. And so if I add that to 61 and I add that to 90, I add all three together. So 61 plus 29 plus 90, confirmed at 180 degrees. Okay, so hopefully on this second pass, these are becoming a little bit easier. It's becoming a little more sensical, a little bit more automatic. That's the whole point of doing the review in this way, is that we can kind of see this build our knowledge. Okay, so again, we're given the three angles of a triangle. Okay, and so I know by rule, if I add these together, I must get 180 degrees. Okay, so that tells me if I take the x, I add the 3x. all these are messed up. Sorry, guys. I just wasn't watching too carefully. And then we take the 2x, add those together. We can actually total 180 degrees. So cleaning up, we have 3, 4, 5, 6 x's is equal to 180. So divide that by 6, x is equal to 30. Okay. So let's put those back into the equation. Let's see if I can hold the color combinations. So x is just going to be 30. 3 times 30 will give us a 90. Oh, we have two 90s here. That's kind of cool. And then we have the red angle. 2 times x is going to be 60. And so if we add those three angles together, 30 plus 60 plus 90, definitely 180 degrees. We are good to go. Okay, let's talk exterior angles. Okay, exterior angle theorem. If we have two interior angles that are not adjacent to a third exterior angle, then we know we can take 5x plus 2, one of the interiors, add the second interior, 64, and that's going to be equal to the exterior value, 12, there it is, x minus 4. Okay? So two angles that are inside but do not touch the exterior, add together, get the exterior. Okay, clean up. So 5x plus 66 is the same as 12x minus 4. Let's solve two parts at the same time. Let's move the 5x to the right. And at the same time, let's move this 4. Wow. Come on, slow computer, you can do it. Let's add this. Let's add 4 to both sides to move the 4 to the left. Okay. So 5x's cancel. This will give us 70. 12 minus 5 is 7x's, and those will cancel too. I'm out of space here, but if I divide by 7s, we have our x to be 10. Okay. And again, we should check, and we should always check. So we have 12. So let's go our exterior angle, 12x minus 4. So 12 times 10 minus 4 is going to be 116. Our red angle, 5x minus 2, so 5 times 10 plus 2. That's going to be 52. And 64 is just going to be 64. So if we add 64 plus 52, we get 116, confirming that we are correct. Cool. Let's keep going. So interior angle. Interior angle equals exterior angle. Okay, solving time. So 4x plus 30. Oh, what is going on? I know what's going on. Too much math is going on. And we're back. Okay, so we have 4x plus 32. It's the same as 8 plus 6x. Let's do a double step again. So let's move the x's to the right, and let's move the 8 to the left. Okay, so we have 32 minus 8, probably 24, but let's check. 32 minus 8, 24. The same as, so these are gone, these are gone. 6x minus 4x is 2x. Divide out the 2's, we get x to be 12. Sweet. So checking that in our values. Red value first. 4 times 12 plus 2, that's going to be 50. Okay. And then 8 plus 6 times 12 is going to be 80. And we definitely see 50 plus a 30 makes the 80. So we're golden. Okay. So we'll write equations in the next part, and then we'll do it all over again.